Okay. I can't quite see how many people in the room, but I think we're ready to get things started. Brian's kindly volunteered to help out with the minutes. I'm not sure if we already had another minute taker, but the more people, all the better. Brian?
Yes, I would love support, but I'm on it as primary.
I'm guessing you're remote from your video. So obviously, if there are people in
Yes.
the room, that is a major benefit, just to catch anything that doesn't quite come through, or to see precisely who's speaking, etc. So
Audio has been pretty good this week, though, so I have high enough confidence to say yes, I will do this.
so be it. Okay. Right then, let's get going. This is the Ietf 122 Quic working group meeting session. If this isn't the room or the session you think you should be in, then just come and stay for the party. This session is being recorded. Yes, before we kick off the main content, we'll always like to take a chance to review the Ietf note. Well, we're halfway through the week, pretty much exactly. So I would presume most of you are familiar with this, but if not, please do familiarize yourself with the documents listed on this page. They describe effectively the code of conduct and the rules of participation in the IETF, and how your participation is a contribution. Particularly a note is how we expect people to conduct themselves when speaking at the mic or interacting with other working group members. And in regards to IPR, intellectual property, anything that you may be familiar with in terms of patents relating to the work that's discussed in this session is subject to the patents of participation as described in BCP 79. Effectively, let it be known or don't participate in the discussion. But as I say, do familiarize yourselves with those documents. Moving on, there's a note really well. Again, it's just to stress that be nice to each other. But if you are or believe you have been subject to anything like harassment, there is an ombuds person's team or the ombuds team that you can reach out to, and they're there to help you and listen to you. This session is being recorded, as already noted. Just in terms of the meeting tips, in-person participation, please use the Meet Echo Lite or the on-site tool. Please scan the QR code, make sure you're in there so we understand participation, which helps future planning, but also to get in the queue and help people like myself and Brian to understand who's speaking when, to manage the queue. If you are remote, like me and Brian, yet again, please make sure your audio and video are off unless sharing or presenting, and using a headset is strongly recommended purely to help the AV. Resources, yes, some links, go and use them if you're having some issues, or ask in the chat. People are generally pretty good at figuring this stuff out now. For admin, we have note takers or a note taker. Please do feel free to dive into that collaborative editing document, even if it's just to maybe view what you said at the mic and check that is representative of what you said. That is always helpful. You'll have a chance later when we post up the draft minutes for any corrections, but doing it now while it's fresh in your mind is always a good thing. The chats via Zulip or the kind of Miyako tool are all integrated and lined up, and me and Matt will be running the queue. For the agenda today, we've got a couple of working group items that we want to talk about. We have quite a large selection of as time permits things this time around. It's a different balance than we're maybe used to, so this should be interesting. In that we have a quick hack received timestamps, extended key update, source buffer management, and then a session at the end about stream multiplexing, which is bringing back a topic we talked about last at Brisbane this time last year, roundabouts. Take a pause there. Does anyone want to bash on that agenda? I'm not seeing anything, so without further ado, we'll move on to the final few chair slides and then open the floor to the multi-path Quic presenter or presenters. So, as you might note, we didn't have the Qlog documents up on this time session because everyone's remote, because there hasn't been like a super load of progress. We didn't feel it really needed much more than this single set of slide. You would have seen earlier in the week we published a new set of documents. The changes there are pretty minimal. A few design issues, a few editorial, and part of the reason for why is that we only have a few issues remaining, 16. Most of those relate to, a group of those relate to TLS, things around resumption, how we articulate key updates, maybe those kinds of aspects. So I know this is quick and it's a transport protocol, but it's a secure one. And making sure that we understand the events relating to handshakes and parameters and restoration is important. So anyone who's more interested in the security angle side, those issues have been open a while. As editors or authors, we've not been able to resolve them necessarily. We will, that's our aim, but any input is always going to be useful. Got a few editorial issues. We're probably fine just working through those ourselves. And then we have the JSON SAC versus other streaming JSON formats as discussed at Ietf 121. We didn't really see any discussion on the list. There's nothing more. It's something that can probably be left for a little while, but we do want to get that resolved before we can group last call. Yeah, I'll leave it there because I don't want to present any view that isn't a chair one. As a note for anyone who isn't tracking the working groups at the Ietf maybe so closely, the Qlog format's an extensible schema, and the idea is other working groups can go and define their own, or maybe bring work here, and we're still trying to figure that out. Are the extension mechanisms we're presenting usable for the purpose that they were made? So this is kind of good. We're seeing a schema for RTP over Quic, one for careful resume, and there's been some discussion there about maybe if that schema wasn't a decent fit or people deemed it not worth or sorry, pick my words closely. That the TSVWG wasn't the right venue to do that work, then maybe would the Quic working group be able to do that? And I think possibly, but ideally, these schemas are designed to articulate events specific to the context or the topic, and so wherever they can be closest to the venue that understands that topic is probably the best. That's something we'll probably look at in the future in terms of how do we as Qlog experts and the foundational help advise or give reviews to Qlog. Something like a Qlog directorate was mooted at the TSVWG discussion earlier in the week. I don't think we quite need to do anything there, but if people are interested, maybe reach out and we can discuss that offline. And then MOCT, media over Quic, is again, it's got Quic in the name. It's related to media, and there's been a kind of on and off request for somebody to do Qlog for them. So I picked that up a couple of months ago, and we're working through that. Maybe we might have something interesting to present at this group. I don't know. We're still kind of figuring it out, early days. Miria, see you in the queue.
Yes, Mia Clement here. So I think about the Qlog that are done in other working groups or here about this question. I think I'm totally fine to it in another working group, especially if I think you need the expertise of the other protocol to do the Qlog right. And then of course you have to coordinate with some of the Quic experts as well. If we want to do that, I think we should make an explicit decision about it and say this is the right way to do it, and maybe even write it down in a sentence in the Qlog draft.
Yeah, I think being clear is useful. Whether it makes sense to talk about process of the Ietf in the technical specifications themselves, I'm not so sure. That's maybe something we need to speak amongst the authors and the RAD or ADs in adjacent groups. I think, yeah, being clear is useful. Whether it makes sense to talk about process of the ITF in the technical specifications themselves, I'm not so sure. That's maybe something we need to speak amongst the authors and the RAD or ADs in adjacent groups.
You were breaking up a little bit. So I think this is a little bit the experience we have for example, IPv6 extensions or whatever. I think they actually, maybe it's even in the charter somewhere, they wrote it down somewhere that it's okay to do that in other working groups and you don't have to do it in 6-man. And I think that has been proven very useful because this question comes up over and over again in my experience.
Okay, no, thank you for that feedback. We'll take that away and I'll raise an issue once I'm done with this session, just so we don't forget that and we can kind of take it there. Okay.
Can I try and talk? I haven't yet got my phone working. So it's Gori Fairhurst. And I'm just thinking about the policy, and maybe we just have to do a little bit of a turn on the IANA equivalent bit of this document to call out clearly what's required to write a new QLog entry. I'm less worried about mirrors thing, because I thought about this, and I think we have ideas about how we do Yang models and MIBs in the past and things, and generally the expertise lay in the working groups, but it was super good to do like a last call in the group that actually owns the core spec. So the process shouldn't be too hard, but let's try and write some guidance down that's really clear in the actual QLog draft. Does that seem reasonable?
No. Yeah, thank you for that feedback.
Just to clarify, I think the process is straightforward and easy. It's just like if you write down that this is the way to do it, then we don't have to discuss it again in future. That's it.
Okay, and then my last slide. The title here is a bit bad, but effectively, back when we were doing a lot of the early quick work, interop and driving the core drafts or the base drafts, as we call them, in that single repo, there were the 4 different documents. We made a lot of use of the wiki to collect notes about things like implementations, interop targets, maybe observance. We didn't have IANA tables at the time, so we collected things like versions or other code points there. And it was quite active and quite well used. But over time, we're done. We've moved our attention elsewhere. We're not using that wiki so much. It was vandalized at one point, and we didn't really pick that up that quickly and had to spend some time restoring it. And effectively now it's become a bit of a graveyard. It's hard to contribute to, it's hard to maintain. It's also that repo that's about 4 documents. But it's a collection of information that's broad about different quick related topics. So to my mind, it's the wrong home for that. I mentioned this on the mailing list around summer last year. It's taking a little bit longer than I would have liked, but the proposal is to revamp the quicwg.org website and make it a lot easier and kind of more familiar with how we do markdown and pull requests to the repository that backs that website, which is hosted under the quicwg.org GitHub repository. Set up a staging website for this to kind of port some of the old wiki content across that makes sense. If you're ever familiar with the implementations wiki, it had a lot of detail about all the draft versions that were supported and other things. I think that's correct, that can be cleared up. So I encourage people to have a look at the staging website. I've got some early feedback and some notes, but the intention is to kind of probably land that and take contributions of anything that we think is missing from the old wiki, archive that wiki. It's locked anyway. I wouldn't look at deleting it, but updating it to make it clear that it's no longer updated. An example of this is recently we had a security researcher reach out who'd found some issue with implementations and was using that website as a kind of a good summary of actively maintained projects who they could reach out to. So I think there's value in this and kind of thing. If there's people who'd be willing to volunteer effort. I'm not a web developer. I hate CSS, so that side of things would be really helpful. But if not, I'm just going to go and proceed with getting this done. And that's it for the chair's updates. Can I invite the multipath presenter to come on up?
Hello, can you hear me?
Yes.
Yeah, would the chair share the slides? Thank you. Okay, let's start. Hello everyone, Yemi from Alibaba, and today we will introduce the updates for multipass extension. Next slide, please. Okay, so first we will have a quick brief summary about the updates from the last two versions and about the hackathon intro reports for the newest version for draft 13. And we have only one left issue to discuss, and then we will talk about the next step for this draft. Next slide, please. Okay, so first about the updates from the last Ietf meeting. At first, we add pass CIDs block the frame as a signal for situations when endpoints don't have unused CIDs for the new passes. And also, we add a recommendation for opening a new pass for active client migration. And that's now means we are not supporting pass migration. We are still supporting pass migration for network bindings, but it's just a recommend to open new paths for active client migration. And also we have add guidance for handling PTO on multiple passes. It's an issue left from the last ITF. And we also add some clarifications. It's not about semantic changes. We're just making things more clear. So we add that the packets should only contain packets which only contains pass ACK frames are not congestion controlled. It's following IPC 9000, but senders still need to take carefully to consider the load introduced by these packets. When endpoints send pass abandon frame but not receive a corresponding pass abandon, it's left for the implementations when to release the pass resources, but it's recommended to wait at least 3 PTOs before remove the issued CIDs of the corresponding pass. And also, it's recommended to always send the pass abandon on another pass because you may have some issues on the to be abandoned pass, like it's turning like a black hole or other issues. And also, we have updated the transport parameter for the new version. Next slide, please. Yeah. So about the newest version, there are very tiny changes. We add one more field called the next sequence number field to the pass IDs block the frame. And we also add recommendation about sending at least one unused CID for all passes up to the max pass ID. And we changed the error code for MP frames in their zero RTT packets to align correctly with IPC 9000. Basically, endpoints should not send MP frames in zero RTT packets. And also, we add some clarifications around the use ACK and retransmissions of these new frames. Basically, all these new frames are ACK illicit. And also, we add guidance on the use of IV and nonce for multiple passes. So next slide, please. About the hackathon interop reports, before this time's hackathon, we already have an online hackathon for draft 12. And so this time, everyone just need to change a little on their implementations to finish all these cases for draft 17. We have 4 clients and 5 servers participate in this time's hackathon, and we have nearly our full table. Thank you for everyone's job. Yeah. So for the issue part, I'd like to switch the microphone to Mira. Mira, please.
Yeah, can you go to the next slide? Somebody? There we go. So I wanted to say we have 0 issues open, but we have 1 issue, but I hope we can just close it. That's my goal here. So that came up during the interim or like the interop testing call that we had. And in the version number 12, where we added this frame, it was actually a little bit unclear what to do with this frame. So we did, in the meantime, add a few words to explain a little bit more when this frame is useful. But it's still not really clear if this frame is useful. Because effectively, if you don't have a CID then it's more like likely an implementation error than something that could happen. Because also in the last version, we recommend now that you should issue CIDs for all possible passes. So like for all pass numbers below the max pass number, you should at least provide one CID so the other end can open a pass. If you want to limit the number of passes that are open, don't just not issue CIDs, just decrease the max pass ID and use that mechanism. So there's no like really valid case where it makes sense to not issue a CID for a pass ID that is valid. And so this is more likely to be an implementation error, and then you send the frame and nothing happened because it's an implementation error, or maybe something happens or whatever. So the question really came up, is that frame really useful? I think there were a little bit mixed feelings about it, maybe more people saying it might not be needed in this call we had, but that was just a small number of people. So effectively, my proposal here is to just keep the frame. We have it already, it's specified, people understand it now. The client can always choose to not implement it, the server can just ignore it. I mean, you shouldn't break if you see the frame, you should at least see it and ignore it, but there's not like it's one line of code or whatever. So we have it specified, let's just keep it. It may or may not be useful. Mike.
Mike Bishop, no hats here. Just these frames are more for debugging than they are for, hey, Pierre, I want you to do something about this. Ideally, none of these should ever hit. You shouldn't be running into these limits because the other side should be refreshing things as you need it.
The pass blocked is a little bit more useful because you give a max pass ID and then you don't know if the other end wants to open a pass or not. It's really not kind of something and the other end can tell you, I actually would like to open a pass. Can you make it happen? That makes it a little bit more useful, but this one is more likely to just be an error.
Yeah, so I think with all of these blocked frames, the main thing I expect an implementation to do is log it. So if somebody cares to look and figure out why the connection's slow, they can. And otherwise, yeah, let's leave it in. You're not expected to do anything with it, just log.
Okay, yep, that's actually a valid use.
Kazuhoka, I agree to what others have said. The blocked frames have turned out to be actually useful for debugging, so let's keep it.
Okay, perfect, easy. That means I'm closing with no action, perfect. And that was the last design issue. There's like one tiny clarification we need to get in, but otherwise we can go to the next slide. Yes, so we are done. No open issues. I'm working on a full editorial path right now. If you look at the current GitHub version, I already reordered the document a little bit so the things follow in the right order and it's easier to read, but I'm also really working on the editorial path. I at least tagged it 2 cases where we changed some text over time and it didn't fit quite that well to the old text, or where something was more or less redundant. So that totally makes sense, hopefully. I'm kind of 2/3 through the document, so I'm not quite done, but hopefully in the next 1 or 2 weeks, and then we're ready and can go for a working group last call. Gory.
Gory Fairhurst, no hats, like that. MinRTT. You've seen I send a few comments and you're probably going to add those to the things to
Yeah, I wanted to say that that's also a few updates that are coming.
Yeah, absolutely, because you're rerunning the text. But MinRTT is mentioned as an entity which might exist not as a path property, but as something which is kind of for the whole world. This seems odd. I thought MinRTT was like the other congestion control parameters and was per path. Is it? That's why I'm asking now, because I think this needs the room to figure out what we mean by MinRTT. Do we have one per path, or do we have one for the whole quick connection?
So there is a section talking about how to calculate round-trip time in MinRTT in the implementation guidance, right? So that's one of the sections. I didn't review it, but it's actually not super easy because there are implementations that decide to send, for example, X always on the shortest or always on the same path. So it's not like MinRTT is actually path property. If you send a packet on one path and you get it back, you get the egg back on another path. And that's something to consider. I think actually that's discussed. So
yeah, right.
So it's not really a path property, but like I agree with you. Usually, if you have different congestion controllers, you probably need different state. But it's kind of left to the implementation to do the right thing here and be not too stupid about it.
Maybe we need slightly more text because I don't want other people to trip up on this again.
Yeah, yeah.
Martin Duke, Google. I did have a chance to quickly look through the draft. I owe you more detailed read, but I do like how the protocol interoperability bits have been coming along. I think it looks pretty solid, logic-wise. What's the deployment status of this?
I think Jan Mai can talk to that. So Alibaba is actually using that, I think, in production, right?
Using it for what? Okay.
Hi. Yeah, actually, we have using it for mobile applications and with our servers. It's transporting both using the Wi-Fi and cellular to accelerate the API requests. It's kind of like using with the HTTP3.
Okay,
Yeah.
so is this like just regular web traffic, or is this 3GPP stuff?
No, it's web traffic.
Okay, that's interesting.
Yeah.
So there is also, this is part of the 3GP specification for ATSSS,
Right.
which is an approach where you have a proxy in the network and then the multipassing is happening between the proxy and the client. But that is not deployed yet because it's kind of brand new. It's in the last stage of specification, so it will be a couple years out before that gets.
I guess what I'm getting at is you know, there's a lot of, I mean, obviously, you know, there's some ITF pros here because the language about scheduling and shared bottleneck congestion control is very carefully worded to not use anything normative so as to not trigger normative references to things that don't exist that are not proposed standards. I don't, I mean, modulo what Alibaba has managed to achieve, I mean, which I'm curious, I would love to hear more about what they're doing regarding those problems, because I don't feel like we as a community know how to do those things in a general use case. Probably in 3GPP we do. If it weren't for 3GPP, I would probably push really strongly for this to be experimental. But you know, I recognize kind of the requirements that they have, and I wonder as maybe as an alternative, I mean, maybe the state is, maybe our state of knowledge is more advanced than I think, and we can write something better in those sections. But if not, I wonder if we could maybe constrain this in the abstract introduction to use cases where we feel real comfortable with how we schedule and congestion control it, and you know, sort of warn people that if they're just going to plug this into just general purpose stuff, like here be dragons and be careful.
Yeah, I mean, first of all, I think I made things more clear in the editorial path that is on GitHub, at least in the introduction. You can read that part already.
Okay. I did not check that. I'll look at the.
But I mainly removed text actually. So we definitely could also say a few more words. I think the Alibaba case is mainly to kind of more improving handover. That's a case that we have some experience with. I think also for multipass TCP, and that's also the case that's at least a little bit more straightforward because you're not really using both links simultaneously, just like for a small period of time, but then still you have to decide when to switch over and whatever. But for ATSSS, I can also say that like in 3GP, there's extra signaling that provides guidance, what to do from the network. So that is kind of more constrained. And also in the ATSSS case, you have this proxy. So you basically tunnel multiple connections over the same proxy, and you probably want to kind of make sure that you only have like one connection on one path and another connection on another path. So this is a different scenario as well. So the case where an application is really using two paths simultaneously, we don't have a lot of experience with. And I think that that's one of the reasons why we would like people to implement and use it and like get this experience and then come back and we can talk more about it.
Yeah, and like again, I understand the intricacies of working 3GPP as well as you, but at least some, and like that to me sounds experimental. But I'm like, I feel very confident that like the 3GPP, you're not going to end up with, you know, shared bottlenecks, stuff like that, and so you can avoid a lot of these problems, and scheduling is probably easier for this traffic flow, and that's great. And you know, the more we can, if we just say proposed standard, you know, use for general use, I think we're staying some confidence in this that we don't have, and I don't want people to just turn this on assuming that it's going to work great, and then it turns out there's real performance problems in very significant use cases. But I think we can massage this with language, and I'll read what you got in the editor's copy, and I'll file an issue if I'm not happy with it. Thanks.
I mean, in this sense, you cannot just implement the draft and turn it on because you need to make decisions about packet scheduling, which are not in the draft, right?
Yeah,
You always
I was going to bring that up.
some-
Just a reminder that MPQuic doesn't have any scheduling or congestion control things specified. That was a deliberate choice in the scope. So I'm just curious, Martin, do you have, like, how is this different from MPTCP or other multipath protocols?
Well, so multipath is a capacious term, right? Multipath, certainly the original definition of MPTCP is failover, right? To be honest, I'm probably lost the state of the art on MPTCP. That's certainly what the core MPTCP stack, and I think we know how to do failover. That's what, I mean, Quic doesn't even call that multipath, even though it's the same capability. We've never standardized a shared bottleneck multipath congestion control. And I think people will default to just run a separate CC on every path, which works in some use cases, maybe doesn't work so great in other use cases.
So first of all, there is text in the draft in the implementation section
Yes.
talking about coupled congestion control. But
Right.
the reason why multipath TCP has coupled congestion control was because we were worried about fairness, not about performance, because it will take more resources when competing with other flows. But I mean,
Yes.
it's very similar to what we had with HTTP 1.1, where you just open 6 connections at one and you get 6 times the throughput, right? So I think,
Fair enough.
yeah.
Okay. Well, yeah, I recognize there's text in there. I might want to move it a little further forward, but again, I haven't read your editor's copy, so I'll do that. Thanks.
Yeah, I will check if I can add something to the introduction. Maybe we can also mention that this failover case is kind of the straightforward one that is a main focus.
As a chair interrupt, I just want to add, Martin, if you would like to volunteer to add text too, as well as just review or open issues, that would be welcome. But also that, we did ship Quic V1 with a kind of statement like stream prioritization and scheduling is really important for the use cases you have, but we don't say anything about them. We don't even provide a mechanism to signal what you would like to do. I think it's okay, speaking more as an individual, for this to be like.
Lucas, you're breaking up very badly.
All right, let me try to respond. So to be clear, I'm not like looking to ship this in some use case that I have, partly because I'm very concerned about some of these issues. And I don't want someone who's not, I don't want the general public or the general RFC reading public to think that we have assessed all of these like very normal use cases and think this is perfectly fine to use. That's all. I'm all for slapping standard on it and like enumerating the use cases where we feel very comfortable with everything we described, but just kind of saying, I've been clear. Thanks.
So I mean, also this version of the draft or this extension will only allow the client to open paths. And that's usually, if you have this case where you have Wi-Fi or a mobile link or whatever, this is usually the site that actually has a knowledge about which path to use. So I think that's the right thing to do there.
So Gary Fairhurst just following up on Martin and commenting that we did 5033 bis, which may be the place to refer to because there is considerations there for schedulers on multipath. And yeah, it says most of the things that that we just said at the mic here. So I think that is probably published as BCP now. So we should be thinking about that when we get to last call, about how we frame that beyond doing the failover case. There might be good text there.
Lars Eggert, Mozilla. So I have a client, right? And we have no plans of implementing multipath TCP, mostly because we don't see any use for it in terms of no server supports it, right? And I haven't talked specifically on this with Safari and Chrome, but I haven't at least heard that they are like looking to ship this either. So it seems like for a vast majority of the Quic speakers out in the internet, this is really sort of not of interest as of yet. And so I have a little bit the same concerns as Martin. I mean, it's great that Alibaba has found a use case between their app and their servers, right? And it's interesting to learn more about what can it do for them. But for almost all things we've done in this working group and also the other Quic related working groups, we had a pretty big, diverse group of implementers. Not everybody, but at least sort of significantly more than one or two to carry something forward as proposed standard. And we would have interop of different implementations. This is one of the strengths of the original sort of Quic development, and we don't have that here.
We have 6 implementation that all
You
interlock.
have Alibaba, which has a deployment. You have a patch to Quiche that I hear is separately maintained, and they might get merged, right? And you have like Pico Quic, which is great, and a few others, but you don't have like the stacks that are shipping a lot of bytes into the network at the moment.
I don't think you should really downplay the Alibaba one though. That is a real app on the real internet. It's just not, China's the real world.
Try to make an exception. I said, other than Alibaba, which I certainly count as a major player on the internet. Thank you for making that even clearer if I didn't manage to do that. I don't see super much support for it from other big players, right? Which is sort of a bit of a concern. Then it is not a complete solution. We just talked about this. So I'm kind of wonder where we go from here. I mean, I don't want to make it experimental, but I also wonder if we can make it, as Martin said, even clearer that this is a few pieces that you might need to build a multipath very quick, but it's certainly nowhere near it. And I kind of also like, since I'm rambling here, stepping back a little bit, so Kostin Raishu gave a talk in ICCRG on what happens in like data centers, right? Where Kostin is one of the original multipath TCP people. And it seems like there's a very different approach being pursued there, which is packet spraying, right? Where you don't have this notion that the transfer protocol needs to maintain these separate paths and manage them and establish them and measure them and have all the complexity around this. You just spray packets to the network, tag them with some entropy that might get them carried along different paths, and then you deal with the outcome at the transport layer in terms of being super robust to reordering and so on. It works quite well in data center networks because of the constraints. We don't quite know if it's going to work for the internet, but I sort of have a feeling that that approach applied to Quic or multipath transport in general is actually probably a more modern approach compared to this sort of very heavyweight path-based thing that comes from SCTP and some earlier research, which is like 20 years old now. And so I kind of wish we would sort of put energy there if I could state a wish.
Yeah, that's now you can start working on it. We're done with multipath Quic, so let's put the energy there.
We're not
But,
done. We're not done with multipath Quic. You just said yourself, right? There's significant pieces that you need to build a solution.
So, but I mean, like
you have frames defined.
Yes.
You can use to talk about paths at the Quic implementation. That's what we have.
Exactly, and we had this discussion 3 years ago, and like we could have had it there, but now we put 3 years of work into that. So I think it's really too late to have this discussion. We have one deployment, we have one big internet player who really depends on this thing, and we have another use case where it's already in a specification from another organization. Let's not rehash this question now. I think that's completely waste of time what you're doing here, honestly.
I don't think it's.
And we are also very because we're only specifying the frames and the frame and like the management. We are very convinced that like the spec is actually doing well because we interopted with multiple implementation. Everybody was able to implement it, right? So there's nothing we're waiting for here for this spec.
You want to go to last call, right? So I think this is exactly the time to have this discussion.
No, this is the discussion you have at adoption time, and
No.
we had it.
No. This is a discussion when you have the product in front of you and you can make a statement about, is this thing that we've worked on actually ready or not? Right? At adoption time, you don't know. I hope this would develop into something else, but it didn't. Right? So I think that would be the time to have this discussion. But I think I've taken enough time. But I'm basically sort of similar to Martin. I feel unhappy with where we are with this document, and I kind of want to find a better way to publish it. I don't know.
Well, I mean, Christian Wittemer, let me give my view of what's happening there. First, I mean, we do have a very clear use case on having a better failover. So that part is very clear. I see on the chat people are discussing the idea of using multipass in peer-to-peer. And we have effectively a scenario that I'm working on that with Martin on doing a peer-to-peer connection for proxy first, and then migrating to a direct connection after some kind of high simulation. That is kind of much better with multipass, and so if multipass was published, it would make that kind of work much better. The other point that I note is that we have a lot of experimentation going on. I mean, I'm fielding queries pretty much every week by different teams of researchers that are asking me. Basically, they are using Quic to do simulation of multipass and to do the experiments, and I'm getting those experiments all the time from multiplicity of places. So there's a huge pent-up interest there to enabling developers. Arguably, that could be done with an experimental RFC, but it's certainly something that is useful.
Brian, we closed the queue, but do you have a direct response to something that has come up?
I actually wanted to reiterate this point. We also had a talk in PanRG about DMTP, which is another sort of like another approach to doing multipass stuff. They're building some stuff on top of Scion at Magdeburg, et cetera, et cetera. And one of the parts of that conversation was like, hey, this seems like another use case for this toolkit that Quic is putting together for the MP stuff, right? Like, so I see that there is a lot of value of having a proposed standard foundation for these sorts of approaches where one, you can do production stuff on it in limited cases, and one, you can also like actually build experimentation for the future. So it's not just the better handover, it's not just the better ice. We don't have to get all the way to this works in general purpose for every single multipath thing in order to use this as a foundation, not just for sort of like limited scope production use, but also for research. So I want to reiterate that I think this is ready at that. We don't have a status between proposed standard and experimental here. So I think it needs to be proposed standard with the caveats that we've been talking about. Thanks.
Cool. I think we can kind of leave it there and move on to the next agenda item. Doing some back channeling with Matt, we take on board the concerns. Like, we don't believe that anything we're hearing should stop us doing a working group last call. That is a perfect opportunity for people to, put further comments in the right places and make sure that we can adapt the document now. So we'll be going ahead with that once the new version's published. We're going to give that probably 4 weeks because it is a large document and we've got things like spring holidays coming up, etc. So we do encourage people look out for that and to give a thorough review once it's started. Thank you. Up next, we have Martin Seaman to talk about address discovery.
Hello, everyone. Next slide, please. Let's talk about address discovery. This draft was adopted after the last meeting. Here's a very quick overview. The problem we are trying to solve is learning your transport reflexive address on a quick connection. So we might have a phone that's using multiple paths. This is not using multipath. This could be like RFC 9000 connection migration path. And it's and the server is providing address observations, basically telling the client, this is the IP address I'm seeing from you on this path. Next slide. How this works is we have an observed address frame. This frame is sent when depending on on what is negotiated during the handshake, which we will talk about later. It's sent when a new path is established or when the remote address changes, for example, due to a net rebinding. And we have MT opened one issue, which I think is we can solve with an editorial change by clarifying that the sequence number in this frame applies to both frame types. so that the sequence that there's only a single sequence number space for both IPv4 and IPv6 address observations. Next slide. This is the second issue that MT opened that I would like to talk about here. The way this extension is currently negotiated is using a transport parameter during the handshake. This transport parameter can have 3 different values. 0 means that I am willing to provide observations, but I'm not interested in receiving any observations myself. 1 is the opposite. I want to receive them, but I'm not willing to send them out. And 2 means both. I want to receive address observations, and I am willing to send them. This is implemented in this negotiation mechanism is implemented in a couple of different Quic stacks. There is a pull request to the Quinn Rust implementation, and it's implemented in Pico Quic as well. And there's a Wireshark dissector to interpret this. And the issue that was raised is that this negotiation is complicated, and we could simplify it by not having any value. Just negotiating this extension means that basically means the option 2 that I'm going to send the frame, and then that I want to receive the frame.
Kazuho?
Kazuho, I prefer status quo because generally speaking, it's a concern for server operators to collect some user-side information, which could be the actual address that the client thinks it's connecting to. So I'd prefer having these status quo and not having the privacy concern at all.
Is MT here? Because he opened the issue and might want to say something. Oh, okay. From what I've heard from implementers, the current way we have is not very complicated to implement. Maybe Christian has some opinion on can share some experience there. But if there's no desire to switch the negotiation mechanism, I would say we should just keep what we currently have. Yeah.
Yeah, Mia Kuhlmann. So, I mean, I actually removed the word negotiation from the multipass document now because it's not a negotiation. It's just like, it's more like one side announcing something. And it's totally fine to just announce I can do it, but I can't send or whatever. So I think that's okay.
Fair enough. I will double check if we're using the word negotiation in the draft, or if I just put it on the slide. Okay, then you can expect a new draft version before the next meeting. Thank you.
Thank you, Martin. Okay, so that's it for the working group items. We're kind of a little bit over the schedule, but still on track if we can keep things tight. So I'd like to invite the presenters for the Quic Act timestamps. Joseph.
Hello, can you hear me?
Yes.
Okay, perfect. Just waiting for the slides. Okay, good afternoon, everyone. Good morning, good evening, if you're not in person. And my name is Joseph Bichet from Meta, and I'm here to talk about the Quic packet receive timestamps that was proposed by Connor Smith and Ian Sweat a couple of years ago. Next slide, please. So why receive timestamps? This was presented before, but just to recap, for better bandwidth estimation is the first goal, especially for real-time congestion control algorithms. In the original draft, this was more motivated by the SQP algorithm, and this is available in a paper that was published by Google a couple of years ago. It is also more important when we acknowledge more packets in a single ACK, such as through the ACK frequency frame extension for Quic. At Meta, we have used this in a Google congestion control derived algorithm for streaming media to be able to improve our bandwidth estimates. One other use case that we have for it is for detecting congestion in the last mile. Sharad had mentioned this in a presentation at the Ietf 118. By observing variations between transmissions and delivery gaps, we can use this to infer physical medium congestion and make decisions based upon that. Next slide, please. So just a little bit of history. This was initially proposed at Ietf 112 by Connor Smith and Ian Sweat. It was brought back with some modifications at Ietf 118 by Sharad from Meta. The idea was to propose 2 new fields to allow reporting out of order timestamps. There's going to be there's an issue open about that. I'll come back to it later. And I'm bringing it back again at this Ietf with a new extension, or like a way to extend the ACK further, so we can carry both ECN fields with the received timestamps and potentially other optional sets of fields as well. Next slide, please. So the overview of the draft: we want to enable the peer to report packet received timestamps for some or all the ACK packets. The timestamp is connection local and is not intended to be absolute. We do this by adding some new fields to the ACK frame. We have the timestamp range count, which tells us how many ranges come after that. And then the actual ranges include a gap, a timestamp delta count, and then the deltas themselves. Next slide, please. The next slide explains how that looks inside the frame. This is what's inside each timestamp range. There is a gap. The gap tells us how many packets are in this range. What's the gap between the packets in this range and either the largest ACK packet from this ACK or from the previous gap, if this is not the first gap in the frame. If this is not the first range in the frame. So for example, if you look at the sequences down there, if we have an ACK with the largest ACK packet number is 100, and then we have 2 timestamp ranges, the first range is going to have a gap, in this case, a gap of 0, because we are ACKing we're adding the timestamp gap for the difference between packet 100 and packet 99, which is in this case 50 microseconds. And then 98 and 97 arrived exactly with 99, so the gaps are zeros, and then 96 has a gap of 1 after 97, and then 95 is 1 millisecond later, or 1 microsecond later after 96. And then the second range has a gap of 3, so it's 3 packets after 95 in this case. And it's, again, 6 is the gap between 92 and 91, etc. Next slide, please. So the previous draft defined all of this with a single ACK received timestamps frame. It carried the existing ACK fields plus the new timestamps field. But received timestamps are not the only set of optional fields we can have. We also need the ACN counts. So the approach we have taken to be able to support this in one implementation is through having instead of having an ACK received timestamps frame, is to have an extended frame that has this new field. It begins with the same fields as the existing ACK frame, and it has a new extra field, which is the extended ACK features. Again, it's a variable length integer, but its bitwise value, the bits in it decide what is actually included in this ACK. So if bit 0 is set, then we know that ECN counts are available in the ACK. If bit 1 is set, then we know that receive timestamps is available in the fields are available in the ACK. Next slide, please. So why an extensible ACK frame? So extensions to the ACK frame currently need to introduce two different variants, one with and another without ECN. If there are more extensions or extension versions to ACKs, then the number of frames we need to support all of the different combinations grows exponentially. So the reasoning behind using an extensible ACK frame with multiple sets of optional fields is that this allows combining the different extensions without having to add more frames for whenever a new extension is added. And because ACKs are one of the most frequently sent frames, the ACK extended frame adds a 1 byte, like an extra 1 byte extended ACK features that decides what else can be included after that. And the sender still has the option to just fall back and send a normal ACK without that extra byte if it doesn't have any data to send. Next slide, please. So currently we have only two issues. The currently open issue number 2 is should timestamps have to be in order, which is required by the current draft because the first timestamp range has the gap calculated from the largest ACK packet number. In Ietf 118, the proposal was to add another field in the ACK in order to change the gap from the first range so that we can report out timestamps for out-of-order packets. You can go back to Ietf 118 and see that proposal. Next slide, please. And this is the more important issue is whether we need the ACK extended frame with multiple optional fields, or we should just do new ACK frame types with ECN and without ECN, or we just extend the existing ACKs and always send timestamps. So the questions here are, would the extended ACK features field, the variable int that decides like whose bits decide what's included, does that require an IANA registry? And if it does, then does the potential of increasing frames justify the IANA overhead of having that extra field? I think that makes sense if we expect to see more extensions that add fields to the ACK. And if we go that route, then is it okay to have two different ways to send ACKs with ECN? Because we could have ACKs with ECN in ACK ECN frame or in the ACK extended frame with the corresponding bit set. So the potential options can be summarized in these 4 options. We can maintain the ACK extended frame approach that I just mentioned earlier. Another option is just to use two new frame types, one for ACK received timestamps and one for ACK ECN received timestamps, which correspond to the existing ACK and ACK ECN with the extra fields. I think this is similar to the approach Christian had proposed in his timestamps draft. The third option is to use one frame with a flag inside the frame to decide whether ECN is included or not. And the fourth option is to not introduce any new frames. And then once the extension is negotiated, always send the received timestamps in ACK or ACK ECN. So once we've negotiated that, we assume that any ACK is going to include received timestamps. Again, this will only consume one extra bit because we have a timestamp ranges count field. That's the first thing in the new received timestamps. So this will cost one extra byte if we don't have any received timestamps once the extension is negotiated. These are the 4 options here. Next slide, and then I can take questions and discuss this further. So the next step is, does the work group think that the extended ACK idea should be pursued? MoveFast has an implementation of 2 iterations of this draft that are usable right now. There's no congestion control in the open source version, but it does log the timestamps in Qlog. So if someone is interested in this, we can do interop. And the more important question, since this is the 3rd time we're bringing this up, is there enough interest to adopt this draft and resume this discussion or not? So with that, yeah, I can take questions.
All right, thanks, Lars Eggert. So I think there's interest. This is a thing that we punted on early on when we did the original Quic work because it was on Google Quic, and we didn't have cycles mentally to deal with it then, and we said if we need it, let's do it later. I think it's a good time. So I'm generally positive. I would love to hear a little bit more about like what you're doing with this information on the congestion control side, but maybe that's a different working group. The thing I actually came up is the previous slide, this whole like extended ACK ECN frame, because we had a version of this discussion again early on when we decided to not make the ACK frame in Quic extensible, but instead define 2 frames, ACK and ACK ECN. And it seems like now you're sort of doing a different design, but what you have, I don't think quite works because you either need to negotiate a version of the ACK ECN frame that implementation support at handshake time, or you cannot skip over unsupported bits that are optional if you don't understand them. So you need a length field in your frame.
Well, that's the ACK extended features flag is what's going to tell us that.
Yeah, so say I don't support a feature that I see a bit set for. So I support the ACK extended frame, but you're setting a bit that I don't understand what it is. It means I don't know how long the thing is that I need to skip over to parse the stuff that I do understand.
That's part of the negotiation. So in the negotiation, each side announces the type, the bits that it can support.
Okay,
and
so you do negotiate.
Both ends, yeah, it has to be negotiated as well.
Yeah, okay. It feels very complicated, but I guess it has to be complicated, which is sort of dissatisfying. Thank you.
So that's the challenge. If we don't think there are potentially more fields that would go in the ACK, then I think this is overly complicated, and we should just go with one of the other easier solutions.
Did I fall off the queue? Okay.
You just go.
Okay, Martin Duke, Google. I'm also here to talk about the frame type bike shed. Yeah, we have lots of frame types. Like, just use more frame types. It's more wire efficient to not have to encode the optionality. Just take as many frame types as you need, and we can add more if we need them.
So the difficulty is not with the amount of frames. Is if there are more optional fields coming later, then that number will grow exponentially depending on how many coexisting extensions you can have.
Yeah, I mean, yes, it'll be 2 to the n extensions, but I think n is small. I don't know if it turns out not to be. We can do something different.
Yeah.
Thanks.
Christian.
Yeah. What about multipath?
Good question. We take suggestions.
No, really. I mean, the reason I say that is that multipath does define its own ACK extension format already. And for a good reason, is because different paths use different sequence number. So there is no way you can mix up the same thing. And so we end up having a path flag. And so we already have a version of the combinatorial problem that you're defining. If you were to do extension, you would need to define 4 more types already.
Mm-hmm.
And so that doesn't seem like a very tenable thing. And so I think that you ought to look at one of 2 solutions. Either have a composable solution, that is basically you don't mess with the existing ACK, but you send a side bag that has the additional information you want, and that would basically be composed with either the multipath or the ACK ECN or whatever. That would be one way. Or the other way is what you mentioned, is that basically we get a negotiation that says all ACK now have this format, and that includes, and in the negotiation, we include that it also applies to multipass acts. But I mean, one of those two things. Okay. Now about the whether we need that level of precision, I'm really not sure, because it turns out that using these timestamps in actual congestion control negotiation is really tricky. You can, but there's a point at which you get too much information. So I love the ECN details. I love being able to say which packets triggered ECN, because that can be tied to congestion control thing. But it's really an explosion of complexity. So we have to be a bit careful there.
Yeah. Yeah. Thanks for the feedback. I think we should consider that as well. Yeah.
Thanks, Christian. Ian Sweat, Google. With my MOQ hat on, I was going to say that I think the demand for this is going to increase quite a bit, because I assume that a lot of people in MOQ are going to use either a variation of GCC or I can never remember, is it Scream? There's a long list of them. Almost all of them require some flavor of this, it seems like. And so I think, so I think now is kind of the time, just from like an MOQ perspective. Putting my Quic hat on, thank you very much, Christian, for bringing up the multipath thing. I completely forgot that you add a new act frame. I think that makes me as an individual go towards number 4 fairly strongly, because it's easy. It's easy to reason about, but that's personal opinion. But I think the multipath bit kind of shoves me more in that direction. And yeah, thank you very much, Christian.
Yeah, so I was going to say something sort of like what Christian said, which is I'm not sure why the timestamps need to be in the same frame as the rest of the ACK. And if you don't have that, then you kind of, solve the combinatorial explosion. You have one frame for the first piece of information you want to add. You have another frame for the next piece of information you want to add, and so on and so forth. I mean, maybe it gets complicated with cross, packetization rules or something. But yeah, but so you might have to. So, okay, so did you want to respond to that?
Yeah. Yes, it is possible, but instead of being able to process the acknowledgement after deserializing it, basically have to make sure that when you packetize things, they get packetized in the same packet, and then B, delay processing acknowledgements until the end, until you've deserialized all frames in the packet. So it's not undoable, but it's a pain.
Okay, that's reasonable. But it's another thing to look at, and that pain is less than the other pain. The other thing
to speak out of my, okay.
Go ahead. Go ahead, Christian.
To speak out of my turn, I mean, what Ian said is true, and that's actually what I do in Quic right now. It's basically not assume that a timestamp is before or after the act that it modifies. In fact, that's simpler to do if the timestamp just says this packet was sent as time t. It gets much harder if you want to carry all the details that, oh, by the way, the ACK of packet number 29 was received at time t plus x, which is additional information. But yes, you need to do that at the end, and that's not terribly hard. I mean, and it's probably a good practice.
So the other question I had is the microsecond resolution you had something that you would consider as a trade-off, or just a number you pulled out says microseconds seem like they should be good?
Oh,
it feels like there is a trade-off between precision and bytes and bits here.
Yeah, and there is this is one of the negotiable parameters. There is an exponent that is negotiated between both sides that decides what value it is. I think the default is microsecond, but there's an exponent.
Okay, so we're going to do a poll, a show of hands on the question of interest for the working group adopting this. Not this specifically this draft necessarily, but just the the topic of acts with received timestamps. So this is not necessarily focusing on that interesting discussion of how we would do it, but rather more should this kind of thing be done. Okay, so I'm going to end it now. For the record, we're going to say we have 32 that voted yes, 0 no's, 8 no opinions, and current attendance is 120. All right, thank you, Joseph.
Great, thank you. Up next, we have the extended key update. I believe Yaroslav is presenting.
I don't know if the clicker works. Let's see. You can just ask Lucas.
Hello, everybody. My name is Yaroslav, and today I would like to present individual draft extended key update for Quic. Hannes and I co-authored that draft together. Next slide, please. So the problem that we're trying to solve is there is only one key exchange in the whole duration of Quic session. So the traditional key update, which in case of Quic is a flip of key phase bit, simply derives new traffic secrets from previous material, which is great for two use cases. One is to overcome ASGCM confidentiality limit, which is around 11 terabytes, a significant number, but can be transferred within a single Quic session. And then it's also useful to keep confidentiality of historic packets in case of compromise. So if compromise happened, then anything before previous key update before compromise would not be visible to the attacker. Next slide, please. Right, so that's what it looks like graphically. So if compromise happened, so for example, somebody stole memory of a process and was able to see the current keys, then with key update, with traditional key update, they would be able to be able to decrypt historic packets until the previous key update. And then they would be able to keep decrypting packets even after a key update has happened, because again, new cryptographic material is derived from the previous one. So once compromise happened, then there is no more future secrecy. So until this connection terminates, disappears, then everything is compromised within that connection. Next slide, please. So the idea of extended key update is to overcome that limit and to introduce capability to do key exchanges in the duration of the session. It's based on extended key update for TLS 1.3, which is adopted draft in TLS working group. It's now going through a FAT process. Unfortunately, we cannot use that draft as it is for Quic, because key updates is a little bit different, because we have this special bit, and if we would be using TLS 1.3 version as it is today, we would have to do trial decryption. So
David, do you have a clarifying question?
Yes. David Skenazy, quick clarifying question on the previous slide. When you say compromise, what do you mean? Like compromise of the memory on one of the devices, compromise of the stream cipher? What are we looking at?
Both, actually. So if you steal memory from an endpoint, and you would figure out keys, then you would be able to decrypt packets that are on the wire until the end of the session.
Thank you.
Okay, could we go back to the, oh, great. Right, so the extended key update triggers a fresh key exchange, and it's using the same TLS group as was used in the initial key exchange between client and server. So it doesn't introduce a potential downgrade of cryptography. So that was one of the issues in previous versions of TLS, that this could be accomplished with renegotiation, and that was a potential attack surface. So we're not reintroducing that attack surface. You cannot change your TLS group. You have to use the same group as before. Extended key update support is negotiated during TLS handshake. So both parties need to agree that they are supporting and willing to use extended key updates. So that's an optional capability. New key exchange messages are using TLS 1.3 messages in CryptoStream, so exact same messages as in the TLS draft. The key differences are, first, we are, instead of confirming that extended key update is complete and we should be switching to the new keys, instead of using a message which is problematic in Quic because of unreliable delivery, we're using that key phase bit in the header that's already there. And because of that, in case of Quic extended key update, if it's negotiated by the parties, it would not be it would be prohibiting traditional key update. So you have to choose if you want to use that traditional key update, or if you negotiated with your peer extended key update, then you would be using only extended key update for the duration of the session. Next slide, please. So that's what we're trying to accomplish here. So minimize the blast radius in case of compromise. So if compromise has happened, so somebody stole memory from endpoint or managed to exploit some vulnerability in the cipher, then that attacker would be able to decrypt only packets between two extended key updates. And again, if you do extended key updates frequently enough, then you could, again, minimize your blast radius. Next slide, please. So why does it matter? There are cases with long-lived sessions where session breaking and re-establishing can be quite disruptive. A few cases that I'm very familiar with, telco signaling. So if these guys are using sessions that could last for days, if not months. Industrial IoT, having a device that would stream some metrics, some performance indicators, some sensor data into your performance collection, sensor collection. TLS session establishment for IoT devices can be energy consuming, and also it would be disruptive. You would lose metrics while your TLS session is being renegotiated. And then last but not least, mask VPNs. So again, if we are building using Quic to build a VPN, site-to-site VPN or remote access VPN, that could last for a long time, and yeah, would be good to do periodic key refresh. IKE, modern IKE v2, modern SSH v2, and not so modern TLS 1.2 and DTLS 1.2 have this capability. So for when people migrate from those protocols into Quic, they, in many cases, would like to retain that capability. SSH in particularly is quite aggressive at frequency of additional key exchanges. And yeah, TLS 1.3 is adopting it. So as I mentioned, it's going through FAT process at the moment. Once this formal process is complete, then it should be going through working group last call. And I think it would be a little bit weird if we would have security capability in TLS 1.3, but not in Quic. Next slide, please. Right, so very briefly how it works. So if during handshake parties negotiated support for extended key update, then either party at any point in time can send a request saying, hey, I would like to do a fresh extended key update, key exchange. Here is my client share. And then the other party would say, yeah, let's do it, and give their part of key share, or it could gracefully decline the request. It could say, I'm too busy, I cannot be bothered, I don't want to do key exchange right now, either permanently or temporary, and give a time in seconds when the other party should retry. So if your peer declined key exchange, it's up to you to decide what to do in that situation. You could either wait and try again, or you could ignore it, or you could terminate the connection. If it's unacceptable to you not to do key update, then you would just terminate the connection. I think that's actually a pretty good improvement compared to the traditional key update where you flip a bit and you expect the other party to comply, and there is no option other than terminate the connection to not comply with that. And yeah, you would confirm that you're using now new keys with Bitflip. Yes, Lars.
So on that one, I don't know if the options actually help you, because you figured that you would only negotiate this extension if you really do want this ability. And it feels kind of weird that then the other side can basically not do it. But with key update, the nice thing is the other side has to do it and you can rely on that. To me, it seems like you want that property. And so if you want to keep it this way, right, the only sane and secure thing is to actually close the connection if you don't get a new key share, because otherwise you're vulnerable, right? And that feels sort of dissatisfying to have this connection.
Yeah, we had this discussion at TLS working group. The reason for this, and that's mimics.
Yeah, but this is for using Quic, and so Quic can decide to do something different than TLS.
Sure. So what I'm trying to say is the reasons for these designs were to introduce DOS protection. So if somebody is abusing your key update, and it's a bit more engaged computationally than
that side can close the connection.
Bitflip, then you could decline it. You could gracefully decline it. Otherwise, declining it could be disruptive. So you have no option to decline it other than terminate the connection.
Okay, so maybe I don't want to hijack this discussion, but I think the trade-offs here might. TLS has a broader application base than Quic, so it might be slightly. Maybe we can come to a simple mechanism that works for Quic.
Okay, yeah. Again, we could modify this message design if we believe that Quic should be more restrictive in terms of declining key updates. Okay, next slide, please. Right. So I have a few questions for the working group. Is this use case relevant for you? So additional security of long-term sessions. Do you have opinion on the solution design? So we already have one. Thanks, Lars. And is it something that working group would like to work on?
Christian Wittemar. I have a couple of issues there. The first issue is that this design forces us to keep the TLS context for the whole duration of the connection. And so that's a trade-off. That's not a pure win. Because if I destroy the TLS context, as soon as the exchange is complete, I minimize the risk of leaking any of its data. So
I think you would need to keep TLS context for a number of other things that might involve crypto frames after the handshake. So for example, if you wanted to do post-handshake authentication of the client, sorry? Oh, it's not allowed in Quic. Yeah, got it.
Yeah, so that there is that. We'll have to understand that. The other point is that you are saying that long-lived session is natural for Quic. I have some practical experience in trying to help people design long-lived session, and my current advice I give them is don't do that. Because long-lived session in Quic, because of the UDP substrate, requires maintaining open ports through the NATs, and that requires a lot of ancillary traffic and timeouts, etc., which is not always a good idea. The typical recommendation is that if you have a long application session, you may want to consider doing that as a series of quick connections that go to session resume and zero RTT and all that, rather than trying to extend a single connection for doing very long, knowing that in any case, that single connection will be limited to 2 to the power 62 bytes. So I think that, I mean, I understand the motivation, it's great, but we have to have some kind of a hard discussion in the working group about what does it mean to have long duration quick connections and what's the best way to do that.
So I'm stepping in his chair here. We are running a little bit low on time, but could people focus their commentary on less on the solution and maybe on the relevance to the working group working on this?
Martin Duke, Google. Yeah, I'm interested in long-term sessions. I would like to see Quic supplant all the SCTP use cases, and one of the important ones is very long-lived sessions. I think that I think we should try to support all the TLS 1.3 features rather than just like decide not to, unless they're like clearly irrelevant. And it doesn't seem like conceptually it should be like a huge implementation lift to just take more stuff and put it to, you know, just keep the crypto stream open for people to, I mean, functionally open to like take more messages that I'm getting for free from a TLS implementation that, you know, I'm using, and Quic is just sort of transport for those messages, and just like, you know, I have to tweak a few APIs to TLS. So it seems like a low software effort, which is good. So I think Christian raises interesting points what to think about regarding like keeping the state, and which is I mean, I think it's a good observation, but I would hope we would find a way to square that circle and pursue this. Thanks.
From your perspective, if we would have an alternative and a design that would not rely on a TLS crypto stream, would that be better? Or do you think it's still not very relevant for Quic since it's not that designed for long-lived sessions?
Well, I mean, I think the crypto stream is less software effort, which is always nice. And the idea of doing some other thing, like not getting the TLS, not being able to reuse the TLS code for this sounds very, very scary to me, for, you know, all the obvious reasons. So I'd much rather just be able to use the TLS code. If it's wrapped differently, just as like everything we do in TLS is like wrapped differently, you know, the record layer or whatever. But I would hate to have to do something weird for Quic for all the actual crypto components to this.
Okay, thank you.
Hi, Rokas here. So I have a question about the use case of this. So you said in case of the key get compromised, the current keys get compromised, you want to be able to renew a different one, right? So my question is like, how do I know that my keys get compromised? Is this going to be like in practice? I'm going to assume that my key gets compromised anyway, and then
yeah. So the way this works, for example, in Ietf or in SSH, you just do it periodically, based on timer or based on amount of volume of data being transferred. So yeah,
right. So we will assume that it would be compromised. So
yeah. So you again, you're reducing your blast radius in case of compromise.
Okay, thank you.
John Mattsson, Ericsson, I think this is very relevant. Best practice when you have any long-term session is to frequently requeue with ephemeral asymmetric crypto, like typically 5 per second SSH, like every hour or some number of gigabytes. And so I think this is needed. The alternative, as Christian said, is to do resumption. There's also an option, but might be more complex for the system. I think Quic should work on this. I think Quic is the future for a lot of systems, and really PPS sent the LS to Ietf also that this is best practice and a requirement for 3GPP infrastructure in general. Yeah.
Thank you.
David Skenazy, Quic enthusiast. So I agree with a lot of what's been said, but I think I'm going to try to make a series of comments that'll make everyone agree. Famous last words, I know. I think that there was a very good point about Quic was designed to encourage shorter-lived sessions. But any protocol like HTTP, for example, that is very much client-initiated, when you're out of client stuff, nuke it, and then do as your RTT when you want to come back up. But if you have something like a mask tunnel where at any point there could be a packet arriving at the server that it needs to be sent over, you can't do that. So I think this makes a lot of sense for those use cases. So I would recommend adding some text to the document explaining the applicability, but that's a solvable problem. In terms of Christian's point about keeping the TLS state, at the end of the day, because you need to do key updates in Quic, you need to keep the previous application secrets so you can derive them. And all this needs you to do on top of that is which key exchange mechanism we set. It's 2 bytes. In practice, what everyone does with Quic is you keep your SSL, your TLS state, and that's that. So that's not a problem. As others have said, definitely keep the crypto stream. Do not invent something new. That would be insane. Generally, the way we do quick extensions like this is you're going to need a transport parameter. What I would recommend to solve Lars' point, which is a good point, is to put the min duration between key updates in the transport parameter. That way you can negotiate that at the Quic layer. And then what you do is the TLS exchange that you have, you keep the same one, but you say must not reject. And if the other side rejects, you blow up the connection. And then you can use the forced key update like we have in Quic, because that's a really nice feature. And so all this to say, I think we can resolve these problems and it's workable. I would recommend adopting.
Thank you. Magnus Westlund Ericsson. I also support this. I think we have a number of use cases. I mean, I've been working hard on trying to get the details for SSTP to function. But I think there's one other aspect around long-lived sessions that we maybe need to think if this should be connected or if it's a separate piece of work. And that's related to mutual reauthentication on the connection level. Because that's not included in this, to my understanding.
Yes, and that's on purpose. We want to keep reauthentication and key updates separate because again, they are solving 2 different issues. One is solving your compromise of memory, and another reauthentication is you have new certificate or you have previous one was revocated, and you need to prove that you are who you are. They may come together, they may be separate. So yes, I think that having re-authentication in Quic is a good idea, but it needs to be a separate piece of work. Yeah. Thank you.
So similar to the last thing, we're going to do a very quick poll or show of hands on the general idea of adoption for this kind of work, the key update topic, not necessarily the broader topic of long-lived sessions. There's a lot of good commentary on that. But this is more specifically on this particular aspect of long-lived sessions. All right, I'm going to cut it there. So we have 26 yes, 2 no, 11 no opinions with 123 in the room. Thank you.
Thank you.
Now we're going to move on to our next topic, which is Stuart.
Just a reminder, these show of hands are a reflection of what's in the room. We'll take further discussion to the list to confirm things there. Thanks.
I don't think it's working, so Lucas has been doing all the slides, so just tell him next slide.
Matt, as if you just go in there's a fake audience member in the Mineco that you can transfer slide control to, and that's how the clicker works.
Ah, that's how that works.
I only have like 4 slides.
Okay, well, Lucas can play Slide Monkey.
I have 10 minutes on the agenda, but I'll try to do this in 5 to make time for our last session.
Thank you.
Let's move on. Bit of a history lesson. Going back almost 15 years, I was working on trying to work out why screen sharing on macOS was so sluggish. This was 2011. I just learned about buffer bloat from Jim Geddes. And I thought, this is buffer bloat. When I clicked on a menu, it took 2 seconds to appear. But when I looked at the packet traces, the network round trip time was like 30 milliseconds. So then I'm scratching my head. And it's like, maybe it's not buffer bloat. Let's move on. Next slide. And this is what was happening. At that time, I was doing screen sharing to my Mac at home in Santa Cruz over a 0.5 megabit DSL line, which doesn't sound like a lot. You might expect screen sharing at a 0.5 megabit to be a horrible experience, and it was a horrible experience, so it kind of met expectations. And that's why nobody debugged it. But when I started looking, the default socket send buffer at that time on macOS was 128 kilobytes. And the socket send buffer serves 2 purposes. It holds the data that's in flight in case it's lost and needs to be retransmitted. So that's important. That's the blue bar. And we want to fill the bandwidth delay product to maximize the use of the available capacity. But the other 125K was just data waiting that hadn't even been sent yet because the congestion control algorithm was correctly determining the right rate to send, and it was holding up the remainder. And that backlog equated to 2 seconds worth of frames. So the screen sharing daemon, which is VNC, remote frame buffer, would grab a frame, compress it, write it to the socket. And the kernel would say, please, sir, may I have some more? It would grab a frame, compress it, write it to the socket, and it would keep jamming data into the socket until it finally blocked, at which point it had 2 seconds of delay built up. So once we understood this, if we go to the next slide, we literally in the space of a week, from identifying this bug to when we had the code checked in, I worked with an engineer at Apple, Padma Boomer, who did the actual work, so credit to her. We checked in a socket option to limit the amount of outstanding unsent data, and suddenly screen sharing was dramatically better. Not like sitting in front of the screen, but definitely usable, whereas it really wasn't before. So we did this, we shipped it, we made it the default for network framework. Every iOS app gets this. Wonderful, right? Didn't really think about it until we started having problems with services from Apple data centers, which don't run iOS, they run Linux. Let's go to the next slide. So that gave me a sense of deja vu. Haven't we solved this already? And it made me realize that I needed to take a broader look at this. We had a side meeting in Dublin that was really well attended. Thank you to everybody who came to that. We talked about expressing the backlog, the red part in that chart, in terms of time, not in terms of bytes. We talked about doing it for other platforms and other APIs. And what's relevant to this group is we talked about doing it for other protocols. And a lot of people I've talked to this week have said, oh, Quic doesn't have this problem because Quic doesn't use sockets. Like I'm a dummy and I don't know that. And Quic isn't in the kernel, it's user space. And Quic uses UDP. So you can't have delay problems with Quic because it's not in the kernel. And I really think that's missing the point. Quic provides a networking API, and client applications use that API. And if you have an application that goes right, sending data, Quic, just like TCP, inside or outside the kernel, has a congestion control algorithm that meters that data into the network at the right rate so as not to overrun the bottleneck. And if the source can generate data faster than that, you get a backlog until you give some kind of back pressure to the application saying, enough, stop, you're just shooting yourself in the foot. The reason I'm presenting this here is to have a discussion about whether there's a problem. And you may all tell me, oh no, we thought of that, it's fine. I have talked to some Quic implementers already this week. Some say, our code doesn't work like that. We don't do any queuing. We don't buffer up data. clients express a desire to send data. In some contexts, this is called a promise, but only when the congestion controller is ready to send the data does it call on that promise and say, okay, now give me the data. That sounds like a good design. I've had other implementers say, oh no, we don't do that. We just build a linked list of blocks waiting to go out. So that is the end of my presentation. This is a call to request people to take a look at the document. If we go on to the next draft, there is and in the PDF version of these slides, these are all clickable links. Oh, I'm sorry, this is my headline. In the last few years, we've finally addressed buffer bloat in the network, and it's been really rewarding seeing Jason Livingood present the good results from Comcast. What is happening is that for a long time, buffer bloat in the network masked buffer bloat in our end systems. And as we fix buffer bloat in the network and things don't really get better, it's exposing the fact that we also have buffer bloat on the sources. So I think it's really important for anything real time, and obviously that includes media over Quic as an obvious candidate. If we don't provide the right feedback to applications to let them know they're building up delay, then we can never build reliable, low latency, real-time applications on top of an API that hides the delay. The last slide has the links to the draft. It is SPM for source buffer management. We have a new non-IETF mailing list. Can we move to the next slide, please? This is why I like having a clicker. There is the draft. Like I said, these are all links in the PDF. There's a mailing list. So please take a look. It's not a very long draft. I hope it's readable, and contribute text either way. We can have an appendix that says this implementation of Quic doesn't have this problem and this is why, and that can become a best practice for all implementations to follow that template. I do not know the answer, but you do, which is why I'm bringing this to raise awareness here. And that is it. Thank you. And I think we have one person in the queue. We did. Ian's gone away. Okay.
No. Yeah, Ian, just be quick.
The queue is locked, so I realized I should not have entered it. That was my mistake. I was going to say that our implementation is pretty good about queuing in, kind of in the Quic layer. But I was told by Lorenzo that in Android, some devices have terrible queuing downstream that I was completely unaware of. And so, like, this is certainly a problem, and probably like it's like my code is okay-ish, but like the other people nearby or applications up and down are probably less good.
Yes, thank you. Yes, so exactly. If the answer is Quic doesn't have this problem, or at least this implementation of Quic doesn't, share the information about how you solve that, because just because not thinking about the problem doesn't mean you don't have a problem, right? If you haven't thought about it, you probably do have a problem. And if you have thought about it, tell us how you solved it.
All right, we're going to move on to Alan with our last topic.
Hi, everybody. I'm going to go, it's only 15 minutes. I'm going to go kind of fast through these slides. So I'm going to talk about what I call QMUX. I made that name up. It was called Quic on Streams when it was presented in Brisbane. And I'm not the draft author. I'm not Kazuho, but I am a Kazuho enthusiast. Okay, next slide. So, okay, so what is in Quic itself? It's got a bunch of different components. At the very top of it, we have this, I put API here. We don't standardize API, but by that I mean, what are the abstractions that Quic provides? Streams, bidirectional, unidirectional streams, the state machine, stop sending, all of that. Then there's framing bits and crypto and congestion control and loss recovery. And UDP, it's like everything. That's everything that's Quic, right? So next slide. All right. Well, it turns out you can take that very top bit, just the multiplexing part, the abstraction, and run it over something else. So there's web transport, which we take just the abstraction piece and we say it's running on top of HTTP. And then we actually allow you to have multiple of these sessions running inside a single HTTP session, for better or for worse. Next slide. And when you think about HTTP, there's actually two components of it, right? There's HTTP3 So that actually is running over Quic underneath, but there's also web transport over HTTP2, and that's running over TCP. But the user is sort of unaware of this, right? So we sort of have this model of like, there's this abstraction, there's this API, and there's lots of different ways to provide that to people. Next slide. So QMUX, or formerly Quic on Streams, is essentially that same thing. We're taking the API bit of Quic, and we're offering it, but over any reliable bidirectional channel. And as sort of a implementation detail, it happens to use the frames that are defined in RFC 9000, but that's not really that important to its function. It's just sort of an implementation detail that makes it convenient. Next slide. So why should we do this? So the stream multiplexing abstraction, it's powerful, it's widely used, it's sort of like how we now think about transport. For many years, like transport just meant a single bidirectional reliable channel, and now it means this thing that Quic sort of invented. This abstraction is now the basis of new protocols like Mach, and some of those want to run both over UDP and not on UDP. And so having a way that is a standard way to talk, to have access to this multiplexing API means that we now have a standard way. We don't have to do bespoke fallback in every new layer 7 protocol that we create. This is also a useful thing for applications and protocols that might never use Quic. So our data center guys at Meta are very persnickety about only TCP right now. But that, if we wanted to take our internal RPC protocol and run it over something, we could run it over QMUX. For some people who think like, okay, there should never be a way to do quick multiplexing over TCP because that's just bad. Well, it turns out you should have been angry in web transport a couple of years ago when we did this over HTTP2. So this already exists. But the dependency on HTTP is really overkill outside of a browser environment. So like, for example, in media over Quic, there's no reason why its TCP fallback would need to go through HTTP2. That doesn't make any sense. And if QMUX had existed, the way web transport over HTTP2 is designed probably would have just used it off the shelf. Instead, it has a very similar set of like frames that it defines in order to implement that. And over the last year, since we met in Brisbane, 3 implementations of Kazuho's Quic on Streams draft have come forward. There was one recently from HA Proxy. So this is something people seem like they want to do. Next slide. Okay, just to be clear, we're not talking about HTTP. Kazuho originally had 2 drafts. The other one was like, how do you do HTTP over this thing? That is clearly an HTTP biz question. And it's my belief that QMUX itself is valuable without this HTTP use case. And so we should really consider it independently. Next slide. Okay, so can we adopt this? Let's go. Next slide. So I'll go ahead and open up the discussion. So what I really want to know is, do you want to see this work move forward? And do you think Quic is the right venue to talk about it, even if we have to make charter modifications? If you don't think Quic is the right venue, what venue do you suggest? So this is like Quispatch. Okay. Great. We're gonna pause there, and I've got a nice queue in 10 minutes. So.
So Gori Fairhurst, absolutely no hats. Just as an individual enthusiast for telling people how wonderful Quic was in replacing TCP, this has a nuanced messaging with it, which says that Quic and TCP have long-lived futures. And I think we have to be extremely careful how we present that message externally if we decide to do this, because I really think the IETF has to decide as a body that that's the right thing to do, because I'm an enthusiast for Quic, and I think that's a successor to TCP perhaps. So let's bear that in mind. Do you have a comment immediately, or do you just want to carry on with the queue?
I mean, maybe my comment is that, like, do we believe reliable bidirectional channels have a long-term future? Not just TCP, right? You can do this over a Unix domain socket, or you can do it over any number of other things. Somebody who wanted me to mention that they're looking at doing some kind of multiplexing over RDMA, and it has a very similar profile. So it's not necessarily an endorsement of TCP by itself.
That's why we need to get the messaging correct, because it's in the Quic working group, and we're talking about in here.
Yeah, I thought by renaming it, I had solved that problem, but thank you.
Sorry.
David Skenazy, almost as enthusiastic as Gory. So I really like that you've split off this from the things on top, especially when it's HTTP on top. I mean, mainly, I wish we had decided to do this like back in the RC 9000 days to have said, while we're doing this, let's also port it to TCP. And then we'd be like, oh, great, we have a HTTP4 or something, and web transport would have been different, but we didn't. So I think the HTTP over this I have concerns about, and like Gory says, you don't want to confuse people, but this individual piece is useful. In terms of the Quick patch question, I think we should quick patch this not to Quic, because, like you said, renaming it away from Quic helps. The messaging away from Quic helps. Putting in the Quic working group goes in the other direction. So I'd like to see this go forward.
Where?
Yeah, TSV area,
No.
TSV working group. Ask Gory to after the plenary.
Okay, thanks.
Eric Kuhner, Apple. Yeah, thank you for this and the presentation. I think Gory's point about audiences matters a lot. There's about 4 distinct audiences for this that all have their own set of carrots and sticks. I'm not as worried about the messaging for HTTP. I think saying that you can run HTTP3 on top of TCP in a compatibility mode is easily understandable. When I say compatibility mode, your first question is great. So I'm not getting all the good things. I'm getting some of the good things. And that's exactly what you get here. So I do think one version of success for this is the ability to run H3 unmodified on top of it, or something very close to unmodified. So I know we were trying to close that door. Maybe
I'm just saying, if you want to talk about HTTP, you're in the wrong room.
that is very true. But anyway, so other than that, I think this is a good thing to do. I think it has taken us some time to emotionally come around to, yeah, maybe there is activation energy enough to do it. But we've been talking about something like this for years, and it, as David noted, it would have drastically simplified a number of other problems, and I don't think those problems are going away.
Do you want to see it done here or in another place?
I actually don't mind doing it here. I think this is the set of people with the right expertise and the set of past pain that will help us avoid future pain.
Okay.
Ian Sweat, Google. As a former editor of some of the Quic documents, I am very glad we did not do this when we did Quic, because that took forever as it is, and adding any more complexity, like we would still be working on it. So as much as that, I do wish we did it immediately after, like the next day. So I do think we might, late's better than never. We should do this. As a MOQ enthusiast, I mean, it's called MOQ, which is Media on Quic. That's wrong. We all know that's kind of a lie. It's already like misbranding. So we've already misbranded that one. It's really media over whatever this thing is, QMux or McStreamy or whatever we want to call it. And then I think the most important thing here is the branding is just, or like the nomenclature is just going to be like incredibly difficult to get right and not confuse the heck out of people.
The good news is the Ietf is great at naming things.
I think you should get like a PR company or something. I don't know. Like, in all seriousness, I think for HTTP it is okay, as Eric said. I think for everything else, or as a general message, I think it's going to be really hard to make sure we do not confuse people, because even within the working group, I mean, when we've discussed this before, it can get very confusing very quickly.
Do you think Quic's the right place to discuss this?
It's the right people, so I mean, you could make them meet in another room.
And Kazuhoka, I think I must apologize for choosing the original name, which turned out to be really terrible. But I think it's good to recall that why we designed Quic and HTTP3 as distinct protocols, and that's because it's not that every application protocol is designed to be operating over HTTP. So I think we should do this. And regarding the group, I think we can do it in Quic because people outside of Ietf doesn't really care which working group is doing what. So the message would be the same regardless of where we do it.
Thanks.
Hi, Lucas. no hats. I took my hat off. You can't see. But speaking as an individual, I have people who really want this thing internally, and lots of people have spoken to me and really excited about this. The thing that excites them is its similarity to Quic stream model. The wiring coding is a nice to have. It's a cool trick or whatever, but it's not that important. It's the fact that we understand how to do a good multi-streaming parallelism, prioritization, etc. It's all compatible, and it makes it easy to build services that chain between whatever the substrate is that the streaming model is running over, which is incredibly powerful to help build the internet deployments that we actually care about. We're not in this single point-to-point client-server model as much as we might like to think. There's load balancers, there's splitting things out, there's doing various other things. So I think there is interest. Personally, for me, I'm very interested. My main concern is if this wasn't to be done in Quic, that we would throw a question out into, well, what's the problem? Let's have 5 different proposals for building a generic multiplexing thing, and the design and the direction goes off in a way that nobody who is interested right now wants, and will lose interest, and that effort will fizzle out. That's what I don't want. Thanks.
Yaroslav Rosamaho, Zscaler. I, as an application developer, obviously having a single API to use whatever transport is available and not worry about UDP is available versus TCP is available is fantastic. So in that sense, I strongly support this work. However, I am not sure if just reusing all the bells and whistles of Quic over, as it exists today, over TCP is the most efficient right way to do it. So I would look into things that maybe instead of just having TCP, we should be looking at TLS over TCP and do some slightly different encoding there. Hence, maybe Quic Working Group is not the right place. Maybe it deserves a separate working group to work on this properly with more transport people involved.
Okay, Lars.
Last second. So I think Gori made a good point that there's an external comms angle here that we should manage carefully, in the sense that we don't want to like give outside of the IETF the appearance that, you know, Quic isn't the great thing that it is, and there's this other great thing that you should like move to now, which this is not, unfortunately, right? But I liked Eric's suggestion that to name it, give it a name that implies degraded functionality, like compatibility mode or something, which sort of, you know, polyfill or whatever. So I think that is fine. I think if we do this, we should do it in this group, because it doesn't make sense otherwise. Yeah, we could have the same people meet with different letters, but the expertise is here, and the group is not sort of super busy compared to what we used to do. So I think this just makes sense if we do it here. Thanks.
I want to be the last man talking on this one. So Colin, Brian, Peter, go ahead. I'll just come after them. Just reserve the slot for me.
I thought you were just going to cut us off. There's 2 ways to achieve that goal. Okay, you know, a simple comment. The obvious name for it is slow, and but I was going to move on with the only thing that's important about this has the same API, and that actually points out the most critical thing, which is we haven't documented that API. What this ought to do is document the API. I'm going to run and hide now that I've said that. But no, I'm serious. I think we ought to document the API, and I think it ought to be done in this working group, because the thing that's critical is that the API of this and the API of Slow and Quic can't diverge, right? They've got to stay the same for whatever parts of the Quic API Slow supports. Yeah, I sort of like it. I think it should be done in this working group, and I also think this working group at the same time should take on actually sort of formalizing a generalized a description of the generalized API for both of them.
Thanks. Brian?
I basically got in line to say exactly what Colin said. I am tired of explaining to students that I teach Quic to that, oh, here's this thing, and oh yeah, by the way, no API. I actually have a slide about the problems that having no API in this space is causing for the continued adoption beyond the initial explosion. And I think that the reason that we didn't do that in the beginning is we didn't understand enough about that API, and in the meantime, we do. And I think that Colin's test here of making sure that we have an API where slow and quick don't diverge is the test that we have for the confidence that we have that we're ready to publish the API. So support the work, support doing it in this working group, very much support the abstract API, at least as a deliverable.
I would just make one quick comment is if for folks who maybe are not in web transport very much, you may want to go take a look at the draft that's called Web Transport Overview, because I think to some degree it may document some of this abstraction. Anyway, Peter.
Piotr Sikora. I also wanted to express support for doing this work, and I think it should be done this working group, especially if we want to consider maybe in the future connection migration from quick to slow or whatever you want to call it.
Thank you.
Go ahead.
Okay, so I'm going to express myself because I have a couple of hours left to do that.
Are you have an AD hat on?
I'm adding an AD hat on. Yes. So I have been listening to this one. I mean, when this first came to me, like, okay, we want to do this. I have been listening. I've been talking with people. So I'm gonna say what my understanding of this thing. So my understanding of this thing, this is a corner case that people who has infrastructure to do this kind of communication, they want to solve. This is not that thing. This is not about replacing Quic or like running Quic over TCP is a bad thing to do. The Quic has some problems, so that's why we're doing it. So I think, and I have been saying in the Slack also, like, okay, actually the look of it, the hear of it depends on how you call it. So I actually like what also Eric said. Say, hey, this is some like compatibility mode or something like that. It is really focused for some HTTP cases, then we are fine. I think, I mean, if the room wants to, the working group wants to do his hair, no problem with that one. But when you are expressing it outside of the world, where we say Quic is a transport protocol, generic transport protocol, is the best thing that we have produced so far. So don't kill that vibe, okay? So that's my suggestion. And so frame it really in a good way. QMax might be a good name. I mean, you're very good at finding good names, so find another perhaps. I don't know.
If it's in the morning and I'm hungry, we can get another scone.
Don't do that either. So all I'm saying, like, I mean, it is the group decides what to do with it, but it doesn't fit into the Quic charter, so you need to recharter Quic, that's for sure. And when you are doing this, make sure that this is viewed as a compatibility mode thing, and this is supporting a corner case, not the thing.
Okay, so thanks for your comments. There were a bunch more slides here to talk about charter, but I realized there was no way we were going to get through them. So
yeah, to be clear, the opinion of the chairs and the outgoing and incoming AD is that this would require a recharter. Also, on the topic of outgoing ADs, we would like to thank Zalhed for his support and Quic over his term. So thank you for everything you've done for supporting the group.
Do you want to just put up the last slide, which just to let people know it exists, and just skip anyway, or not review the slides if you're interested? Yes.
Yeah.
We might need to change the charter if you're interested in what that might look like.
Yeah, and we'll follow up with mail to the list on what that process will look like and how that discussion will evolve. So yeah, we're done with this meeting. Thank you, everyone, and thank you especially Brian for taking your notes.
Oh, is it? Yeah. Fun. I think we're in this. Yeah, you probably are.